In this video, we're going to take a look at exam revision for completing the square. So the idea behind this video is just to take a look at some exam style questions for completing the square. So if we jump into the first question here, we're asked to write x squared minus 10x plus 4 in this form here. Now this form here is what we call completed square form. So as soon as you see a quadratic and it asks for the quadratic to be put into this form here, you need to recognize that that is completing the square. Now it says a and b are integers. Remember, an integer is just a whole number. Can be positive, can be negative. Okay. So where do we begin here on completing the square? Well, what I need to do here is halve the value of this coefficient of x here. So I'm going to get x minus 5. We square this bracket like we can see here. So I square that. What I do now is I subtract this value squared. So minus 5 squared would be positive 25, but we subtract that off. So I get minus 25. And then don't forget the part we've got left over here. Okay, so plus 4. So minus 25 plus 4. What I need to do now is simplify. So I'm going to get x minus 5 all squared. Minus 25 plus 4, that will give me minus 21. We get minus 21 there. And there we have it. That is our solution. It's as easy as that. So what I can do now is identify the values of a and b, because we're asked to find the values of a and b here. So a is minus 5. That's this value here inside the bracket. And b then is this term here, this constant on the outside. So it's going to be minus 21. Okay. And there we have it. So that's our solution. Notice a and b here are integers. Obviously, if we got, say, a equals a half, then we'd know we'd done it wrong because a half isn't an integer. So we'd have to double check our solution. So obviously, just use that as a bit of a guide. But there we have it. So that's our solution to question 1. Taking a look at question 2 here, we've got the curve C, which has the equation y equals x squared minus 6x plus 14. Now for part A, we're asked to express the curve C in the form y equals x plus a all squared plus b, where a and b are integers to be found again. So what we need to do here is take this quadratic and put it into completed square form. Okay. Remember, the first thing we do here is we halve the coefficient of x here. So half of minus 6 is minus 3. What I'm going to get here is x minus 3. All squared. We subtract this value squared here. So minus 3 squared would be positive 9, but we subtract this, so I'm going to get minus 9. And then don't forget plus 14. Okay, so plus 14. What I need to do now is simplify here. So the x minus 3 doesn't change. So x minus 3 all squared. And then I've got minus 9 plus 14, which is the same as 14 minus 9. So what I'm going to get there is plus 5, positive 5. And there we have it, that's our solution. So what I need to do is actually put it into this form here. So therefore, y is equal to x minus 3 all squared, x minus 3 all squared, plus b, which in this case is plus 5. And if we identify the value of a and b here, a is equal to minus 3, and b is equal to 5. Okay, so that's our solution to part A. Now part B says, hence or otherwise, find the coordinates of the turning point of the curve C. So if we think about sketching this quadratic here, I don't know exactly what this is going to look like, but for example, it might look, say, something like this. Okay, it's going to have this U shape, I know that, but without doing any further work, I don't know where it's going to cut through the x-axis here. Okay, now clearly this would cut through the y-axis at positive 14, so my sketch here is definitely not correct. But just so we can understand the idea here behind the turning point. So the turning point here will be the minimum point of this quadratic. So that's going to be, say, here. Okay. In other words, it's where the quadratic stops going down, like we can see here, and instead changes to going up, like we can see then from there on. So that's what we're looking for. We're looking for these coordinates. Okay. So how do we do that? Well, once we've got something in completed square form like this, it's actually quite easy. So if we take this form here, so x minus 3 all squared, plus 5, then the coordinates of the turning point here, so turning point, they're given from the completed square form. So you don't need to do any other work here. All we need to do is read off the coordinates. So the x coordinate is given by this bracket here. Now be very careful. It's not going to be minus 3, but it will be positive 3 for the x coordinate. So if this is x minus 3, the turning point, the x coordinate of the turning point is positive 3. If it would have been x plus 3, then it would have been minus 3. Okay, if this is x minus 1, the x coordinate would have been positive 1. Okay, so you can see that it's the opposite sign. And then the y coordinate here is given by this constant here on the outside. So that doesn't change. So if that's plus 5, it'll be positive 5 here for us as well. Okay. And there we have it. So that's the turning point of the curve C there, giving us a solution to question 2. Taking a look at question 3 now, what we've got here is this quadratic. So 2x squared minus 12x minus 18. And we're asked to write it in this form here. So again, you need to recognize this as completing the square. And we're told that a, b, and c are integers to be found. And remember, an integer is just a whole number. So where do we begin with this? And what makes this one slightly more complicated here is because our coefficient of x squared is not 1. Okay. So when the coefficient of x squared here isn't 1, you need to do a bit of extra work before you can actually complete the square. And what I'm going to do here is I'm going to factor this coefficient out. Okay. I'm going to factor 2 out here from this whole quadratic. We're going to get 2 lots of x squared. So we take the 2 out here on the outside. I'm going to get x squared. I'm going to get minus 6x. And then finally, this minus 18 would become minus 9. Okay. Now, because the coefficient here of x squared is 1, we can now complete the square on this quadratic here inside the square brackets. So keep the 2 here on the outside. We don't do anything with that yet. So inside the brackets now, completing the square on this quadratic, we're going to get x minus 3. So x minus 3 all squared. Subtract this value squared, so that's minus 9. And don't forget we've got another minus 9 here as well. Okay. What I need to do now is simplify the square bracket here. So we get 2 lots of x minus 3 all squared. So x minus 3 all squared. Minus 9 minus another 9 gives me minus 18. Okay. Now what I want here is something in this form. Okay. So what I need to do now is multiply through by this number here, 2 on the outside with everything inside the square bracket. So in that case, we're going to get 2 lots of x minus 3 all squared. So 2 lots of x minus 3 all squared. And then 2 times minus 18 would give me minus 36 there. Okay. And at this point here, now we have completed the square on this original quadratic here. Okay. So I just need to identify now the values of a, b, and c. So in that case, a here is this value outside the bracket, which would be this 2. B here is the value inside the bracket, like we can see here, so that would be minus 3. And then finally, C here is this constant on the outside, which would be minus 36 there. Okay. And there we have it, so that's our solution to question 3. Moving on to question 4 now, we have a question here that looks slightly different. And the reason for that is because normally we're given the quadratic and we're asked to complete the square to find the complete square form. However, this time what we've got is the complete square form here, and we're asked to find the original quadratic. So how do we do this? What we need to do is work backwards. So if we've got the completed square form here, I need to work backwards by expanding these double brackets here, and then we're going to subtract 5 off that result there. Okay, so x plus 4 squared. This is the product of 2 brackets here, so that's x plus 4 times x plus 4. So expand these out using FOIL or any method that you're familiar with. I'm going to get x squared. So we get x squared, 4x, and then I'm going to get another 4x there. So that's 8x in total. And then finally 4 times 4 gives me 16. So what I've got here for this quadratic corresponds to this part here. So don't forget the minus 5. So I'm now going to subtract 5 off as well. And what I need to do now is simplify. So I'm going to get x squared. I've got 8x here. And then finally 16 minus 5 would give me 11. So we get plus 11 there. Okay. And from here now we can identify the values of b and c. So therefore b is equal to the coefficient here of x, which would be 8. And c will be the constant term at the end here, which is 11. And there we have it. So that's our solution to question 4. Taking a look at question 5 here, it says by completing the square, find the minimum point of the curve y equals x squared minus 3x plus 1. So to find the minimum point here, remember, we're just looking for the completed square form. So let's just start by completing the square on this quadratic equation here. Now what's going to make this slightly trickier is this coefficient here of b, or the coefficient of x. When I divide that by 2 and I half it, we're going to get a fraction, okay? Because my coefficient here of b is not an even number. But let's just carry on for now and we'll see what happens. So I'm going to get x minus 3 over 2 all squared. And remember, we subtract this value squared. So 3 over 2 squared, or minus 3 over 2 squared, that would give me 9 over 4. That would normally be positive, but we subtract that off, so I'm going to subtract 9 over 4 off. And then don't forget we've got plus 1 here left over. We've got a plus 1 here left over. Now what I need to do here is simplify. Now you'd be expected to do this without a calculator, so I'm going to have x minus 3 over 2 squared. I've then got minus 9 over 4 plus 1. So if you add 1 to this fraction here, we need to get this over a common denominator. So this 1 here, we need to times that by 4, both numerator and denominator here. So that's the same as 1 over 1. So I times that by 4, I get plus 4 over 4 there. Okay. Which in this case is going to give me minus 5 over 4. Because they've now got a common denominator, I can just do minus 9 over 4 plus 4 over 4, giving me minus 5 over 4. And then from here, we can actually just identify the minimum point of the curve. We know it's going to be a minimum point because it's a positive quadratic, so if you sketch it, it's going to look, say, something like that. Okay, it's got this U shape. So from here then, the minimum point is going to be equal. So remember, this x coordinate is given by this minus 3 over 2 here, but we change the sign. So rather than it being minus 3 over 2, that would be positive 3 over 2. And the y coordinate is given from this part here on the outside, but that doesn't change. So if it's minus 5 over 4, that's what we take it as. So minus 5 over 4 there. And there we have it. So that's the coordinates of the minimum point of the curve y equals x squared minus 3x plus 1, giving us a solution to question 5. Taking a look at question 6 here, it says by completing the square, solve the equation x squared minus 10x plus 3 is equal to 0. So how do we solve an equation by completing the square? Well, the first thing I need to do here is get this into completed square form. So we're going to have the coefficient of x here. We're going to get x minus 5 all squared. So we now subtract minus 5 squared, so that's going to be minus 25. And then we add 3. Okay. So what do we do next here? Well, I'm going to simplify. So I'm going to get x minus 5 all squared. So minus 25 plus 3, that would be minus 22. And this is all equal to 0. So these two expressions here are equivalent. Okay, so in that case, then if x squared minus 10x plus 3 is equal to 0, then x minus 5 all squared minus 22 must also be equal to 0. So what I want to do here now is rearrange and make x the subject. So the first thing I'm going to do here is get rid of this minus 22. And to do that, I'm going to add 22 to both sides. Okay, so add 22 to both sides. I get x minus 5 all squared. It's going to be equal to 22. Now we want to get rid of this square here. So to do the, to get rid of the square here, we do the opposite, and I'm going to square root both sides. So I'm going to get x minus 5 here on the left-hand side. Now on the right-hand side here, take care. When you square root this, because we're looking to solve an equation, we're going to have two solutions. We're going to have the positive solution and the negative solution. So we need a plus or minus in front of the square root. Okay, so that's the square root of 22. And then finally, we just want x here. Remember, we're making x a subject. So to do that, I need to add 5 to both sides. So plus 5 to both sides. And then what I get here, so therefore x is equal to 5 plus or minus the square root of 22. Okay. And there we have it. That's our solution to the equation. So what I've got there is technically two solutions. I've got x equals, if I just do this here, I've got one solution of x equals 5 plus square root of 22. And I've also got a solution here of x equals 5 minus the square root of 22. Okay. Like you can see, this plus or minus splits the solution up here into two separate solutions. But if we write it like that, it kind of looks like one, but just do take note that that's actually two solutions. Okay. So there we have it. So that's the solution to question 6. And finally, taking a look at the very last question here, we've been told that the minimum point of the quadratic wave equation 2x squared plus bx plus c is given as 4 minus 1. It says using the coordinates of the minimum point, find the value of b and c. So where do we begin with a question like this? Well, the first thing I'm going to note here is that the minimum point, so the minimum point here is 4 minus 1. Okay. So why is that important? Well, it's important because if we know the coordinates of the minimum point, we can work backwards by obtaining the completed square form, and then we can obtain the original quadratic by expanding and simplifying. Okay, so we need the completed square form here. So if my x coordinate is 4, that means the bracket here will be x minus 4 all squared. Okay, if that had been, say, minus 4 here for the x coordinate, then that would have been x plus 4 all squared. So you can see how that changes things. My y coordinate here is minus 1, so we include that here for the completed square form. Okay, so that would be minus 1. But we need to be very, very careful here, because we're told that the original quadratic here, for the coefficient of x squared, that's 2. Okay, so what that means is for our completed square form, we'll have a 2 here on the front like that. So what I need to do now is expand and simplify this expression here. Okay, so applying BIDMAS here, I need to expand this bracket here first. So x minus 4 squared, that's the same as x minus 4 times x minus 4. So expanding here using Euler any method that you're familiar with, I'm going to get x squared, I'm going to get minus 4x and then another minus 4x. So in total there we've got minus 8x. And then finally minus 4 times minus 4 would give me positive 16. So we get positive 16 there. So what I'm doing is I'm taking that quadratic and I'm timing it by 2. Okay, that's what we're doing here. So I get 2 lots of x squared minus 8x and then plus 16. And then don't forget we've got this minus 1 here on the outside. So again, just using BIDMAS here, and I need to multiply this 2 here with this bracket. So I'm going to get 2x squared. 2 times minus 8x, that will give me minus 16x. So minus 16x. And then finally 2 times 16 gives me 32. And then don't forget we've got this minus 1 here. So it's really easy to miss this minus 1, but we still need to include it. And all I need to do now to finish here is just simplify this quadratic. So I'm going to get 2x squared. We've got minus 16x here. We can't do anything else with that. And then I've got 32 minus 1 giving me positive 31 there. And there we have it, that's our solution. So we can now identify the value of b and c. So b here is a coefficient of x, which would be minus 16. And in that case, c is equal to the constant at the end, which is 31. And there we have it, so that's our solution. So like you can see, certainly a tricky question. More than anything, it's just tricky to get started with that question. It's not particularly easy to see where we start with. But I think once you kind of get going with that question, it unravels quite nicely. Okay. But there we have it, so that brings us to the end of this video on exam revision for completing the square.